We talked about some super basic introductory statistical information. And now we got to talk about what it's kind of like to be a researcher. The person who's posed the question, trying to gather data, and going to use that data to make some type of conclusion. Because ultimately, that's what statistics is all about. It's evidence that proves a point, demonstrates a point, supports or disproves an opinion. Okay, it's the evidence. So we got to talk about how to get the data. Okay, and there's lots of different ways to do it. We're actually going to talk about 5 different ways, even though what it's about to say is there's 4. This is how the book goes. The book says there's 4 ways. Oh, but there's others too, and we'll talk about those sort of second. And so that's how I presented it the same way. Okay. So let's talk about ways of collecting data. And in this world of interesting media, it seems like objective reporting has gone away. At least that's that people are trying to get us to believe. Okay? And that there are some groups of people that want to put out information that speaks to a specific point of view. And some of these ways may lend themselves to those point of views, or they may lend themselves to be more objective. And we'll get into that kind of stuff here later. But understand that that's what this is kind of all about. Some of these methods are better than others to get objective information. So, there are surveys. You guys have all done a survey before. Anymore, we do it electronically, where you have some type of questionnaire. You fill out a Survey Monkey. It gets sent into the researcher, and it instantly collects the data, and then the researcher can look at it and decide what they want to do with it. All right. A lot of times it's used just to make a simple, quick decision, and it can be done at the front end in terms of setting the survey up can be done pretty easily. Now, again, remember this book is old. So this book was written before there was Survey Monkey. So it was pen and paper, and you'd fill it out. Maybe there was a bubble Scantron sheet that you had to bubble in as well. Every year is it Valentine's Day that they do that date matching thing here? Don't you do that on paper? Same kind of idea. Okay, so that's a survey. The people giving their information, that data is collected. Okay, that's one way. Another way is surveying records. Now that means the data is already there, and the researcher is combing through the data and picking out the parts that they're interested in looking at. For example, if I wanted to know how many 11th grade girls there were at the school, I could go through the database and I could do a sort and look at just the number of girls and count it up that way. So that would be one example of surveying records. You could have a table that you had that has a bunch of data in it, and you were going to go through that and investigate that data, analyze. Another way to look at this might be analyzing records versus surveying records. Okay, so that's another way to collect data. And the third way that we're going to look at is direct observation. Now this is one where it's typically something like this. Let's say you wanted to know, you're thinking about putting a street light, like you're thinking about putting a street light in, I don't know, I don't remember the name of the street right here, and you come up from the neighborhood right over here, then come up to Sunrise toward the school. There's a stop sign right there, right? Right before you could go into sort of the back of the school. Like, let's say you were trying to decide if you want to put a street light there. Maybe the traffic is too crazy and people are running stop signs, and so maybe you just sat there in a chair with a chart, with a clipboard, and you decided you were going to find out how many people actually stop at the stop sign versus sort of roll through it. And you wanted to keep track of that to use as evidence that, you know what, people aren't really following this the way they should. Maybe we need a street light there to prevent accidents. That's an example, okay? When I taught statistics course before, there was an investigation where they talked about whether or not high school kids wash their hands after using the bathroom. Okay? And so there were lots of different ways to do it, but one of the ways that they were collecting was by direct observation. Now, they weren't just parked in the bathroom watching you. They were posing as another person in the bathroom washing their hands. So they would just kind of hang out in the bathroom, but they looked like they were supposed to be there. And so they were documenting, not video documenting, but recording whether or not the kids were washing their hands. And let's just say the results were a little, they weren't good. So that's another example of direct observation. So the researcher is literally watching, observing, and recording data based on behavior. Okay, and they're gonna take that data and make conclusions with it. Okay, so those are 3 different ways of collecting data that we'll talk about. Okay. Any questions on those 3? 4 basic sampling techniques, and again, this is where I'm actually going to give you 5. Okay. 1 just isn't that common because it's not. You'll see in a sec why we don't talk about it too much. Okay. So the first one is random sampling. So the subjects are selected completely by chance. There's no rhyme or reason to how the people participating in the study are selected. It's 100% completely random. That's the first one. Second one, systematic sampling. Systematic sampling. So each subject in the population is given a number, and then it's like every third person, every multiple of 3 gets selected. So if I assign numbers to all of you and I wanted to do it that way, then I would use the information from 3, 6, 9, 12, 15. All of you would have a number assigned to you. And once those numbers are assigned, a system is created to choose who gets to participate in the research. Stratified sampling. Now this one's a little more complex. So you take the population and you divide it into some groups that have common characteristics. So the example that we're given here is if we're at a high school, we're going to talk about freshmen as one group, sophomores one group, juniors one group, seniors one group. Okay. Then from the group, you select randomly. So this is where it's similar to random sampling, but it's sort of random sampling within each group of that population. So it's sort of sectioned off and then random inside of that. That's what stratified sampling is. Those groups are called strata. And then the last one, just kidding, there's going to be a 5th one. Cluster sampling. So that would be like me just surveying you. You're all clustered together in my class already. If I was going to do research and I wanted to use cluster sampling, I would just pick this group because you're right here. Or maybe I would pick this group in Mr. Herding's room because it's all in the G building now, the gym, right? So they're all kind of clustered together. Oftentimes it's by proximity. Just one group that's all kind of near each other. And this one kind of ties into the next one that I'm going to show you, even though I said there's only 4. There's a relationship. It's not always a direct relationship, but there's some similarities there. Okay? So, cluster. Cluster sampling, subjects are selected from intact groups. Okay? So there's already a set of groups, and they're selected from there. Random is just random. So let's go back and see. There are other ones, and the most common other one is called convenience sampling. So I could survey you as a group, your cluster together, but it's also convenient for me. Like, I don't have to run around and talk to a whole bunch of other people and get their opinion. Convenience sampling is about the researcher, making it easier on themselves. Okay, and that's what this says. It's about being convenient to the researcher. Here's what one of the issues is with convenience sampling. Okay, the validity comes into question. Like, if all I'm ever doing to gather data is asking the kids in my class, I'm not getting a full representation of our school. Let's say I was trying to make a determination about which week to have late starts when we get to the 3 wishes. And all I did was ask you guys. Okay? So freshmen didn't get a voice, sophomores didn't get a voice, most of the juniors didn't get a voice. Okay? So that might be convenient for me, but is it fully representative of our school population? I think it's pretty easy to conclude that it isn't. All right? But that's not going to prevent people from using one of those type of sampling methods. So this is what I was talking about at the beginning. The researcher, typically a researcher is not going in completely objective, right? When you form a hypothesis in science class, you're sort of making an educated guess about where you're going to end up, right? That's what research kind of works. You don't go into it completely blind. And depending on what you want your results to be, now sometimes it is completely. Let me qualify that. True objective research should be done without the end in mind. You go into the experiment or the investigation, and the results lead you to where they lead you, and you draw your conclusion based on the data that you have. But as I was talking about earlier, with some claims within our media, you have specific groups who are trying to put a specific message out to get you to think a certain way. So if they're going to be using some type of sampling method, they're probably going to choose something that's going to give them the answer that supports their opinion. So now they go, oh, well, the research states that da-da-da-da-da. See, I was right. My opinion is valid. So you have to be careful with statistics. You have to understand who's doing the research. Do they have an angle? Are they trying to get you to perceive the situation a certain way? And so each of these different sampling methods can contribute to that. So that's the thing about statistics that you got to be careful of. Because if I choose the sampling method that's going to benefit me as a researcher, you have to question the validity of the study. If it's completely objective and the results are the results, okay, that gives you a different impression. And in our age of social media and instant media, okay, it's easy to not be as critical of the things that you see and read. But I want you to try to start taking a more critical eye when you look at whatever it is you're looking at and decide, how true is it? How objective is it? Is there an angle here? And if there is, you should question its validity. Okay? And I will tell you that it's harder and harder and harder in this day and age of social media to decide what is true and what is quote-unquote fake news. Okay? It's harder to do that now than it ever was before. Have you seen some of the technology where they can take a person and make the person on video say whatever they want them to say, and it looks like they're the one talking? Have you guys seen that at all? It's kind of scary, actually. So just be on the lookout for that. All right, rant over. Next, I'm going to go through 4 examples. Now, for each of these examples, if you want to take a picture of the example instead of writing it all out, that'll save us a little bit of time. If you want to write it all out, that's fine too. So we're going to go through some examples, and you have to decide, is it random, systematic, stratified, or cluster sampling? Okay? So here's the first one. Then go ahead and write underneath it what you think it is. What is it? Systematic. The key thing here is every 5th sale. Okay? So every 5th sale, when you assign a number to it and then choose systematically who you're going to visit in this case, okay, that is systematic. Okay, how many had that? Very good. All right, let's look at another one. Again, take a picture and write down the answer. So, through your discussions, did you come to a resolution, conclusion? Yeah. What do you think? Cluster. Cluster. What else do you think?
Cluster.
Random. So which is it? Is it random or cluster? Cluster. Right? So let's look. Let's go back and look at the definition real quick. Okay. Let's actually. Okay. So here we go. What part of this statement makes it not completely random?
They're all in the same vicinity.
They're doing the city blocks.
100 blocks. Same city. 100
Okay.
city blocks.
There's only 100 city blocks being chosen. Okay. So there's a portion of the whole thing that is being selected, and then within that is random. Okay. So that's the key. There's a qualifier. They've eliminated part of the city, even though those 100 were selected at random. Okay, there's only 100. Now we don't know enough about this city, and we don't know how many blocks there are, but we make the assumption that there's a lot more than 100. The answer is cluster sampling. Okay, it's a little tricky. It's a little tricky. Okay, question. So if they told us how many total city blocks there were, okay, then that would be more information that would allow us to make a better decision about which one it was, but they don't give us that. So we have to make the assumption that it's not that close, that 100 is a small portion of the city, okay? So that's where it gets a little tricky, okay? All right, next one. Okay, do the same thing. Discuss amongst yourselves. See if you have some agreement here. More agreement than the last time. What is it? What is it? Stratified. How do we know that it's stratified? What gives it away?
The strata.
The strata, which are the groups. So we split them into groups first. So we've got 3 groups, and then inside of those 3 groups we select randomly. So it's sort of dividing it up, and when you divide it into specific groups, specific categories, there's some characteristic in common about each of those groups, and then you select randomly inside of those groups. That's stratified sampling. Okay. All right, last one. Well, there's only one left, but let's make sure it actually is that. There's only one left. It is random. Now let's talk about why it is random. There's some key qualities in this descriptor that tells us that it's random. First of all, it says assigned ID numbers to all its employees. That means the entire population got a number. Everyone in the population got a chance to be selected. And when everyone in the population, or everything in the population, has an opportunity to play, then there's a chance that it can be random. Okay? Now, if a computer generates numbers, and we assume that it's not a evil, vicious computer, and it's going to be completely random. Okay, so that's the key. To be a true random sampling situation, all members of the population have to have an opportunity to be selected. Okay, if they don't, it can't be purely random. It can be mostly random, but not purely random. And ultimately, at the end of the day, the most objective type of sampling to get the truest, purest results, you have to use random sampling. Okay? And so we will get into some of that stuff as we continue through this course. Okay, are there any questions? Again, like I said, there's a lot of vocabulary, a lot of definitions and things that we need to know as we move forward to get started with this, and then we'll be in good shape. All right.